Hello, hello, my dear students. Today I
Yeah,
am taking up a small chapter known as expansion. Okay, so let us see what is why why it is needed to learn this chapter. It helps in doing several mathematical questions, bringing the question in a very shorter way. So suppose we are needed to multiply two quantities or two expressions like mm, x plus a multiplied by x plus b. Okay, so here
tradition.
traditionally what we do traditionally means that we are doing in our previous classes in class 7 class, correct? So what we do, we we were doing like this: x plus a multiplied by x, correct, plus x plus a multiplied by b, correct. So this is known as distributive property. This is by distributive property. Everyone knows this by distributive property, correct? Because what distributed, x plus b is distributed over x plus a. Okay, now when we proceed further, it becomes, now open the bracket, we get x square plus ax plus xb plus ab, correct? So now what happens, x square, on further solving, it becomes a plus b multiplied by x plus ab. Now if you remember my lecture number 8, uh, when I was teaching you about factorization of trinomials, it was of the form, if you remember my lecture number 7, px plus q. Understood? I said to break p in terms of two quantities, a plus b, and q as a product of two numbers, that is integer numbers. This is the same thing. Okay, so in short, in short, in short, what is what I mean to say, in short, I mean to say, whenever you see two expressions like this, two binomial expression like this, you need to multiply, don't go for traditional multiplication. Just traditional means the long way of multiplication. Just adopt the system, sum of the terms a plus b multiplied by x and product of a and b, correct? So in the same way, we can take up the products of other forms. Suppose I want to show you by examples. Let us, if we are asked to multiply two numbers like x plus 3 if I asked to multiply x plus 3 multiply by x plus 4, directly you can write by following this formula. You can write it as 4 plus 3 7. Okay, I'm writing here for explanation, otherwise no need to write. Okay, 4 into 3, correct. So it will become x square plus 7x plus 12. You can write it directly, correct. Now in the same way, if I asked to multiply two numbers, suppose it is x minus 3 and another number is x plus 4. Okay, so x square plus sum of the numbers plus product of the numbers, correct. It will be x square plus x minus 12. So I think you understood. So if we formulate a rule for this, if we want to formulate some rule, or mean to say if we want to give it the shape of the formula, what we can do, we can write it as x minus a. Suppose we are multiplying two expressions, x minus a, x minus b. We will write it as x square plus, put the plus sign here, minus a minus b, inside plus product of a and b. It will become plus, no need to write, or okay, I'm writing it, minus b, correct. So it will be x square minus a plus b. I have taken the minus sign common, okay, plus ab, correct. Another expression can be x minus a, let us say, and x plus b. We can directly, this time we will write directly x square plus b minus a multiplied by x plus minus ab. Okay, now let us see some more expression like x minus x plus a and x minus b. So this will be x square plus a minus b into x minus ab. Okay, so this is suppose this is second number, this is third number, this is fourth number. So I hope you understand how to multiply two binomial numbers of this form. Okay, let us now take up another form which is often asked in question, like as you know, yes, we did it in our last chapter also, in the chapter of factorization, like x minus a, x plus a. We have done this chapter of factorization. Here we can put it directly as a square, because we know it. We have the idea of the identity. Otherwise, if you want to expand, you can do it in this way. Okay. So another form can be this is form number 5. You can put it down at form number 5, expansion. Another thing, if I am asked to multiply two quantities such that ax plus by into cx plus dy. So what will be the product? Simply first into first, that will be acx square, put it like this, plus last into last bd y square. Okay, now ax with dy, so ad plus by plus c into cx, that is bc xy. So this is question 6 number. So try to learn this formulas. It will help you a lot while solving questions without going through big multiplying process. So let us take up some questions, okay, which will make you feel better. Like suppose we are asked to multiply two numbers xy plus 6w multiplied by 3xy minus 4w. The question will using some identity. Okay, so simply first with first, it will be 3x square y square plus last with last, so 6 fours are this with this, last with last, 24 w square. Correct. Now first into last plus, see the sign always 3. Now put the sign here, then first into, see this first into this, first into first, last into last. Now cross xy with 4w. Okay, xy with 4w, just wait. xy with 4w, it will make, sorry, yeah, xy with 4w. So inside the bracket you can put minus 4 xy with 4w and this with this, 6 with 3, 6 3s are 18, so plus 18, common term will be xyw. Correct. So our answer will be 3x square y square minus 24 w square. What will happen to this? 4 plus 14, 14, put 14 x y w. This is the answer for this question number 1. Correct. Now let us come to some another question. The questions are simpler, but it needs some practice. If you are asked to multiply two numbers 5 minus x, okay, multiply it with x plus 8, x plus 8. Okay, you can do it both the ways, like by taking sum or making the form same. Okay, how to make the form same? Let us see. You can take minus sign common, we can make it x minus 5 and x plus 8, correct? Okay, now what we can do, x square, as we know, put the minus sign outside the bracket. This is minus sign outside, this minus sign is here inside the bracket. X square, puts plus sign here, sum of the term 8 minus 5 x plus the product. Product is plus minus minus 40, so it will become minus x square 3x minus 40. Now open the bracket and multiply with minus sign, so it will become 40 minus 3x minus x square. This is the answer. Okay. Okay, now let us can we take some more questions on this? Okay, let us take some more question on this. By 2x, let us take a question. Multiply, the question will give you like this: multiply 2x plus x with 3x plus 4. Simply 2 3 or 6. First of all, 6 x square plus sum of the terms. See, first into first, last into last. 6 4s are 24 plus first into last. Whenever you are applying this type of formula, make it look like same, like we have x terms first, 2x plus 6, and in the second expression we have 3x plus 4. Okay, so in this way, so first into first, last into last, plus first into last, 4 2s are 8, plus last into first, 6 3s are 18, correct, taking x common, so it will be 6x square plus 24, 18 plus 8, 18 19 20 21 22 23 24 25 26, so it will be plus 26x. This is your answer, correct? So this is the answer. Okay, now it is asked to let us see, let us take some question number 4. It is there asking find find 7x minus 3 multiplied by 3x minus 3 3x minus 3 by inspection. By inspection. Okay, so how we will proceed? How we will proceed? Simply, see, we have our form of the expression is same in both the expressions. Okay, so first into first, 7 3s are 21 x square. Okay, last into last, 3 3s are 9 plus 9, put plus sign, put a bracket inside the bracket, first into last, 7 3s are 21, minus 21, okay, with x. Okay, you can put it x here, otherwise we will write x outside. Okay, and this last into first, 3 3s are 9, minus 9 x. We can take x inside also, so we will take it during finalizing. X square plus 9, see both are minus sign, so we will take minus out, so 21 plus 9 30, so it will become 30x. So we can write it as 21x square minus 30x. If you want to write in this way, you can write it. It is minus 9 plus 9. So this is our answer, 21x square minus 30x plus 9. Okay, so this is, I think, in questions of class 7, class 8, class 9, they asked to multiply given binomials, not by going through long way of multiplication, but by using some identity or using some short form. Okay, so suppose let us take some more question, like we have done how many questions, like this was question number 4. Now let us take question number 5. Question number 5. Okay, question number 5, it is asked to multiply x square plus 3 multiplied with x square minus 8. Let us say it is asked to multiply these two quantities. Okay, same. First into first, it will become x4, last into last, see the sign, 8 3s are 24. Now put plus sign here, first into last, minus 8, this last into this first, plus 3, with the coefficient, so with x square, this is the common term. So finally what we get, x4, if we sum up we will get minus 5 x square minus 24. So this is our answer for question number 5. Okay, I hope you are getting the question, the solution, the process that we are taking up. So in this way you can take up more questions and solve it. Okay, let us take up some examples. If we were asked to expand, as we know, we have studied the expansions of the term. We have already studied expansions of in our earlier classes. We have studied expansion of a plus b whole square. We have studied it is a square plus b square plus 2ab, correct? Okay, we have already also studied a minus b whole square, that is a square plus b square minus 2ab, correct? These expansion we have studied in our earlier classes. Okay, I mean to say in our earlier lecture. Now if we add these two expression, it will become a minus b whole square, what we get? We get 2 times of a square plus b square. Correct? And if we subtract these two quantities, I mean to say these two expressions, what we get? It is 4ab. You can find it. Okay, you can reduce these expression, and if we multiply this a plus b with a minus b, what we get? This we have studied. We get a square minus b square. So this we have studied in our earlier lecture. So just wait, students. Okay, so this we did, this we have done, this we have done. Okay, what I mean to say, you need to learn the formulas. Okay, you need to learn these formula. It will help you in solving questions. You need to learn these formulas. Okay, this will help you in learning, and it will help you in solving many more questions. So please learn these two formulas. Okay, now suppose I'm taking some questions like this is question number, I think it is question number 7 or 6, whatever. If we are asked to expand a minus b minus c with a minus b plus c, what will happen? What will you do? See the question carefully, and please kindly note that we can put this bracket inside this small bracket. We can put the given expression as like this. It will become what we can see, it is a plus b, a minus b. So this is a square minus b square, correct? And if we expand it, we will get a square plus b square minus 2ab plus c square. So this is our answer, correct? Now okay, let us take a question number 8, correct? Let us see, these questions are easy, but you need to practice it more and more. It will help you. 1 minus x. Okay, it said expand this. So what we will do? Simply, if you see, it is very obvious. What obvious? 1 plus x and 1 minus x. It is 1 minus x square. 1 plus x square, correct? And multiply, we will get 1 minus x to the power 4. So this is our answer for this question, correct? So there are more questions on expansion and using the formula, like suppose, what is the expansion of let us just wait. Now I'm putting it like expansion of x plus 1 upon x. Okay, so it is expansion of x plus 1 upon x. Rather, you should put it a square here, because we cannot expand x plus 1 upon x. Okay, so x plus 1 upon x whole square will become, you know, by applying a plus b whole square, what we get, a square plus b square plus 2ab. What is a? In place of a it is x. What is b? This is b. So cancelling this term with this term, we get x square plus 1 upon x square plus 2. So this is the expansion of x plus 1 upon x whole square. Okay, students. Now if we are asked to write expansion of now we are asked to write expansion of x minus 1 upon x whole square. You can write directly x square plus 1 upon x square minus 2. In the same way, using a minus b whole square formula. Correct. So what is next? There may be some questions I think these are very simple questions. Just wait. Take some simple questions like 4x upon 5 question, like just putting for this. Okay, question number 9, 4x upon 5 plus plus y upon 3 whole square. Asked to expand it simply by using a plus b whole square formula. What we get, 16. You can put it directly if you want, you can. Otherwise you have to write like this by breaking the things each and every time, every term. A square plus b square. What is b? Y plus 3 is in place of b. B square plus 2ab. What is 2? 2 is 2. What is a? It is 4x. This is a. What is b? B is y upon 3. Correct. So when you open this bracket, it will become 16x square, 16 upon 25x square plus 1 upon 9 y square plus 4 to the 8 xy upon 5 3 is a 15. So this is the answer for question number 9. So the questions are not so much difficult, so you can do it in this way. Okay, so now a difficult question, question number 10. If it is given, Suppose if x plus 1 upon x is equal to given it is given say 4. Okay, find x square plus 1 upon x square. Okay, we need to find the value of this. How we will find out the value? Simply x plus 1 upon x, we will square the term on both the sides, so it will become 4 square. It is given, so we can do it squaring both sides. You can write squaring both sides. We will get x square plus 1 upon x square plus 2ab by applying a plus b whole square formula is equal to 16. What we can see, x cancelled, so we can find out x square plus 1 upon x square is equal to 16 minus 2. It is, so x square plus 1 upon x square is equal to 14. So this is the answer for this question number 10. So students, you can note down the questions and solutions if you want to note down, and if you have some problems in understanding, you can put a comment. In our next class, we will take up some more questions on this chapter of expansion, and we'll try to find out the value of other expressions, okay, as it is shown in question number 10. So by then, take care. Goodbye students. Thank you.